Welcome to this series of lessons about unit, dimension and measurement. In this series, we discuss the unit, dimension and measurement chapter in three small parts. In the first lesson, we discuss about physical quantity and unit. In the second lesson is about dimension analysis, and the third one is about measurement and error analysis. So let's start it. In our world, anything we observe, there are mainly two types. Some properties like smell, taste, color, etc. of matter are subject to qualitative observation only. We use our sense organs to perceive this. On the other hand, some properties like mass, volume, and density of matter, etc. are subject to qualitative as well as quantitative observation, and measurement is an integral part of quantitative observation. What is physical quantity? The characteristics of matter or any physical event that can be expressed as measurable quantity are called physical quantity. So, mass of a body is a physical quantity while its smell is not. Let's say a car is moving from point A to B. Anything that we can measure in this physical event? Think. Yes, here we can measure how much distance traveled by the car, how much time spent to travel that distance, and in what speed the car is moving. So, physical quantity of in this event are distance, time, and speed. One of the most important targets of physics is to measure physical quantity with accuracy. There are two types of physical quantity. Some are called fundamental or base quantities. There are only 7 fundamental quantities. These are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. These 7 quantities are independent of other physical quantity and not defined in terms of other physical quantity. On the other hand, all other physical quantities which are expressed in terms of fundamental quantities are called derived quantities. To understand it better, let's back to the previous example. Here we find distance, time and speed are physical quantity. Distance and time are fundamental physical quantity because these are independent of other physical quantities, and speed is a derivative quantities because we define speed as a distance travel at unit time. That means speed is expressed in terms of distance and time, which are fundamental quantities. Any measured physical quantities has two parts. One is numerical value or magnitude, and other is unit. What is unit? Unit is the standard amount of physical quantity chosen to measure the physical quantity of same kind. The standard of measurement of any physical quantity is represented by 1, and the name of the unit is written beside 1. Take an example. Suppose the length of a rod is 5 meter. Here, length is a physical quantity, meter is the unit of the length, and digit 5 implies that the length is 5 times the value of 1 meter. There are mainly 3 basic unit systems have been used. These are CGS system, FPS system, and MKS system. In CGS system, unit of length taken as a 1 centimeter, unit of mass as a 1 gram, and unit of time as a 1 second. In FPS system, unit of length is 1 feet, unit of mass is 1 pound, and unit of time is 1 second. And in MKS system, unit of length is 1 meter, unit of mass is 1 kg, and unit of time is 1 second. And there is also another unit system called SI system. It is similar to MKS system and most commonly used. This is the table on 7 fundamental quantities and their SI unit. The SI unit of length is meter, mass in SI unit kilogram, time in SI unit second, electric current in SI unit ampere, thermodynamic temperature in SI unit Kelvin, amount of substance in SI unit candela, and luminous intensity in SI unit mole. Besides 7 fundamental quantities, there are another 2 supplementary quantities. They are plane angle and its unit is radian, and solid angle and its unit is steradian.